Cool.
Cool. Here we are. Well, hello, fellow attendees. Today is the 5th of December, and according to our schedules here at Novedge, we have another exciting and informative live Novedge Best of the Best webinar today. In today's Novedge webinar, episode 60, Edwin Braun of cebas Visual Technology Incorporated will give us a live presentation on Thinking Particles 5.0 for 3DX Max and 3DX Max design. It is a truly powerful integration of a fully procedural effects technique embedded in the tool's core, allowing the simulation preview and modification of different physics effects based on multiple solver algorithms in real time. A little bit about our host, Edwin Braun. He started cebas 2 years after high school with a partner in Germany to code RISC processors, databases, and machine controllers. Braun and his partner then expanded the company's software development business, and in the late 1990s started to specialize in CAD, 3D visualization, and animation technology. In 2009, cebas Visual Technology relocated its headquarters and is now based in the beautiful Victoria in British Columbia. cebas's new approach with Thinking Particles in their product is it combines the technology of the industry's leading physics solver, Bullet, with Thinking Particles' unique rule-based particle system. Together with Edwin Braun as our guide, we'll learn about Thinking Particles 5.0, the idea behind its functionality and concept origins, Thinking Particles user interface and the results it can achieve, and how has Thinking Particles affected the world of visual effects in movies and games, the latest changes in Thinking Particles and how those changes cater to artists and the overall industry demands. And lastly, Edwin will wrap it all up with a summary of facts, features, and key points. The presentation itself will be about 40 minutes long, and in just a bit, Edwin will take over the rest of the presentation. If you have any questions at any time during the presentation, I encourage you guys to please post them into the chat window so we can answer them during the Q&A session. Today's webinar will be recorded live, so if you want to rewatch episode 60 in its entirety, as always, you can find it on our Novedge webinar series channel through Vimeo and YouTube. And with that said, I will happily let Edwin take over the podium. Edwin, are you there? Edwin?
Yes, I'm here. And
oh, cool.
Yes, I'm here and ready.
All right. Okay. I will change presenter to you right about now.
Okay. Okay, here we go. I think, let me just check this one here. So everyone should be able to see my screen now, which is a 3D Studio Max 2012 right now. Our products run on all available versions of 3D Studio Max down to 2010. And I'm going to talk about our Thinking Particles 5.0 now. Thinking Particles 5 is a particle effect system, but it goes way beyond just particles. You can do amazing things with Thinking Particles. And it's used in, or it was used in all the major blockbuster movies this year, including The Avengers, Snow White and the Huntsman, Spider-Man 4, and all these main blockbuster movies. And one reason why 3D Studio Max and Thinking Particles is a good combination is its flexibility and the way it works. And the key to its success is the fully procedural approach to everything. So every effect, every little bit in Thinking Particles is fully procedural. And I would like to show you or explain what this means. So we have Thinking Particles in here. We have a pretty simple scene. Let me just play back the scene and explain what's happening here. Because this little scene really shows the key things Thinking Particles all about. So what you can see here is we are emitting particles on the left side from this box here. And these particles are traveling just straight, and they are passing these three spheres. And as you can see, let me just zoom in a little bit. With every particle passing, it starts as a triangle, and you can see these particles pass the first sphere, and it's turned into a cube. They pass the second sphere, it's turned into a sphere, and it passes the third, and it's turned into this rectangle. So right now, that's not really so amazing and great. However, it explains very well the idea about thinking particles, because that's a procedural setup. And that's what all the pros love about it. You can now change everything as you like without redoing your effects work. So this is not pre-recorded. This is happening on the fly. So let me just show you. If I go back to frame 0, and for example, I want to move this sphere, I'll move that over here. You will see that the final result will be completely different. We only have one sphere, one particle turned into a sphere, because we're just grazing here the second sphere. And that's the great thing. Depending on where my sphere is, I will have a change of my particle animation. So if I go back, particles fly, you see when they are passing through this sphere, they are turned into spheres. So that's the key idea, that once you have did the setup for your special effect, you don't have to redo your work. You just adjust the environment, you adjust the settings, and that's it. But you don't have to redo the effect. So how do we do that? How can we tell if a particle hits this sphere, it should turn the particle into a sphere, and in this case we say if it hits this particle, the particle is turned into a cube. So how do we do that? And that's, as I said, a fully procedural approach. So the idea is that you don't have to be a programmer or a fancy person to learn coding or things like that. You would just go into thinking particles, and as you can see here, we have, let me just close this one, we have the thinking particles user interface. The thinking particles user interface is a node-based interface. So you do everything, all the magic happens with wiring your nodes or operators. So you don't have to learn a programming or scripting language. You just draw a wire and you set up the whole scene or effect. And that's a very flexible thing. It's fully hierarchical. You have full control over every aspect, and it's as easy as just drawing wires. So let me just explain what we have here. So I'm closing what we call these little dynamic sets here. Every little dynamic set here, right now I have selected the born dynamic set. Let me just fold this up. So this dynamic set is pretty simple. It has one node, and this node is called the matter waves born. So that node has a lot of inputs and outputs, and I can turn on all these inputs and outputs, or we just go ahead and we enable all the inputs and outputs. I can say visible all, and then we see we have a huge, complex, powerful node that has a lot of inputs and outputs. And every one of these little controls here, you can control with another node. But for now, we are fine with just the matter waves born, which is just responsible in creating particles. Right now, we have a constant particle count in our scene. So if a particle dies, a new one is born. We have a count of 100. So if I want to increase the particle count, I would just type in 300, like you know it from 3D Studio Max. Let me just minimize this. And now if we start again our simulation, we will have just much more particles emitting from our box here. So from the main user interface, and you can see we have now more cubes here. So from the workflow and how everything works, it's all like 3D Studio Max. So there's not a lot of new user interfaces you have to learn or ways how things work. You select a node, you will get your rollout menu here, like you would see it in 3D Studio Max. When you select an object, you get a rollout menu here with your modifiers and this stuff. It's the same deal here with our Thinking Particles user interface. In here, you select a node, you get its parameters on the right-hand side. Up here, like in 3D Studio Max, we have various operators or controls or nodes we can choose from. And that works the same. It's a hierarchical system, so you have standard, you have drop-down menus, so you can access all your nodes in here very fast and easy. Okay, let me get back to the scene how this is set up. So we have the matter wave spawn that's responsible for our emission of the particles. So if we have done this, we go to, so we have now our particle emitter. We go to the next dynamic set. I've selected the Born shape here. So right now we have another dynamic set that controls now our particles that are born in group 1. And Thinking Particles has a hierarchical particle group concept. So you can put all your groups, all your particles in separate groups. I will talk later about what you can do with groups. It's a very powerful system. But for now, we just assume, okay, we can access now our particles that are born from matter waves. We can access these particles with this output, the particle output. And the particle output means you have just all the information a particle can have. So a particle can have, for example, speed, age, a spin, and all these parameters, a mass, all these additional parameters a particle can have, you can access through this node. So we feed in this particle into our first condition operator. So we have a condition, and that's particle age. So we want to have something happening based on a particle age. And right now I've selected particle age, so you will see we have here our controls for the particle age node, and you see we have the born condition. So when a particle is born, something should happen. So I just have the radio button born on here. And when the particle is born, we create an output. So whenever a particle is created with our first dynamic set, the matter waves, we activate this node. I'm selecting now this node here. So the standard shape node assigns to this newly born particle, and only when it's born, it assigns it a shape. And we have chosen a triangle. We can choose various shapes, but as you've seen in the live view, when the particle is created, let me just minimize that, we create it as a triangle. So our particles are born from this box here as triangles. So that's what we are controlling here. So all our particles, when they are born as triangles. So this dynamic set only assigns an initial shape to our particle. And that's the real power of Thinking Particles. You can procedurally assign shapes. As I said, right now we have the condition when a particle is born. We can say, okay, when a particle is dying, we can do something else. We can activate another thing. So we can, for example, say when a particle dies, I want to create 2 new particles or 3 more particles or whatever I want to do. So once you have this setup going, it just works in the scene and you don't have to redo your effects anymore. So the next dynamic set we have here is our sphere 1. That's, if you remember, that's the first sphere we have here. So this first sphere turns the particles into cubes. So let's see how this is working. What we have here is the dynamic set that works again with our particles from group 1. That's where the initial triangles are born. We take the particle information and we take the position. So we can output various parameters from this node. So this node can supply us with the particle information, with the position, with the velocity, the lifespan, age, size, spin, alignment. You see it there. So we can access all this information of a particle at any time, at any place in our dynamic set. So right now we feed in the position to our distance node. So you guessed right, so we're going to measure the distance. We want to know how far is this particle away from our first sphere. So we have the first position coming from the particle that was born. The second position is coming from a node, helper or node. And in here you can see we have picked sphere 1. Over here on the right-hand side you see this node has picked sphere 1. So we get the position, we output the position. So we're measuring right now the distance between these 2 points, our sphere and the particle that was born. And if that lies between 0 and 15 units, this node activates our standard shape node. And then we assign a cube. So that's a pretty simple setup, but that shows very clear the power of thinking particles, because that is rule-based. It does not matter how many particles you have. You can have 1,000,000 particles, 10,000 particles, 1 particle. Whenever this condition is true, it will turn this particle into a cube. So that's the beauty about it. If you have set up your rules and your effect, it will always work, independent of time, independent of any other surrounding. As long as you have particles that can get close to this object, this thing will work. And that makes thinking particles so powerful and so flexible. And this goes through the whole thinking particles product. You have no restriction about the fully procedural approach. So whenever you feel like it, you can set up these rules and they will just work. And then later, if the director comes back to you and says, okay, I have a crazy idea, I want more spaceships. No problem, you just dial in more particles, your scene setup will still work. It's so easy to adjust your effects without redoing work. No keyframes needed. Remember, I didn't talk about keyframes at all. You don't have to do the classic animation thing where you set keyframes. You still can do that if you want, but right now, here's no single keyframe used. And that's the great thing. Let me now show you right now, let me just minimize that. If we animate here and do some modifications, let's say I'm moving this sphere here, moving around, you see nothing happens really. So I have to move the scene, go back and play again, and then you will see, okay, we are now turning these particles into spheres. So you have to redo all your positioning and then play again the stuff. Sometimes you don't want that. Sometimes you really want to see in real time how your particle system behaves. It's maybe easier to adjust, or it feels just better to adjust these effects. And yes, we can do this as well. We have a very special function. We call that edit on the fly. So if this button is active, it means you have to just simulate or redo your particle animation. So if I turn this button off, you will see our particle system will instantly update. So I'm going now back to frame 0, and now when I play, it looks like before. Let me just move to this position. It looks like before. So we have now our particles here. Those one over here are turned into spheres. But now when I move or do anything to my particle setup, it changes in real time. I hope you can see the screen updates there. So as I move my sphere around, I see immediately my procedural effect. So thinking particles is really powerful and can do all these procedural things in real time. However, in some situations, when you're going really crazy, like the big guys, when they do a collapse of a skyscraper or multiple collapses of objects, they usually turn off this real-time feedback calculation feature, because if you have a few 100,000 particles in a physics simulation, it can take some time when you do that. So that's why we have this functionality and feature to turn off edit on the fly. So if I turn this on again, when I'm moving my sphere, you will see it does not update. I would have to go back to frame 0, and then when I'm back at frame 0, you would have to play back the whole simulation again. So that's another helpful thing we have here in Thinking Particles when you do real complex special effects, like a plane crash, or, as I said, a house or skyscraper crumbling down and falling into pieces. Okay, that was my starting scene to explain the main idea about thinking particles. It's this fully procedural approach, and it goes much, much deeper than you have seen here. You can have this fully procedural approach in every single aspect. It goes even into a non-linear, a full non-linear behavior of animations when you do animations, and I will show that later as well. Okay, let me just reset the scene here and show you when you do something from scratch. How would that work? How does it compare to a normal particle system? So I would now work like a normal particle system, how easy it is to just do everyday things when you have to do some smoke, dust effects and things. So you would just go to your particle systems. You will find Thinking Particles, and you would just click this little helper in here. So that's the first a little bit unusual thing. You just click this helper in here. Nothing happens. There will be no effects. If I go in the frames time slider, nothing happens. Okay, I just created a Thinking Particles helper. However, this is the most powerful thing that handles your whole Thinking Particle simulation and system. And what we get very often is, can I add a second one? Yes, sure. You can add a second Thinking Particles. Now I have 2 Thinking Particles here. Should you do that? Sometimes. But we do recommend, and you will learn that very, very soon, you only need 1 Thinking Particle system in your scene. Why? If you use 2 Thinking Particles systems in your scene, they don't know about each other. So you can have objects here. Let's say you have in this Thinking Particles, you have a spaceship or whatever, and in this you have your wall. You can't make the spaceship crash into this wall because these are 2 separate particle simulations and particle systems. So we say if you want to have a real interaction with all objects in the scene, you use only 1 Thinking Particle. So I will delete the second one here and go back to the first one. So we have created this helper, and now let me bring up our Thinking Particles user interface. And then you might say, okay, how do I start? I want to have a particle. Let's say we just want to have a spray particles thing. The first thing you should do is you should create your table or desktop. So what you want to do is, and that's always a good habit, and I tell it everyone every time, you can name everything, and please do so, because if you have group, 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 later you won't know what it means or what it does. So you would just go here, create your first particle group, and let's just name it spray. And the important thing is we can have these hierarchies. I talked a little bit about that. So we can create another group, and let's name this rocks, for example. Oops, rocks. And we can have another particle group, and let's name this particle group dust. So we have these groups. And now the great thing is, when you create particles in your thinking particle system, you can decide where these particles go. And these particle groups can be accessed from all the nodes. And the great thing is, it works in hierarchies. So we can have the dust and spray, for example, in one group. I'm moving that now under spray. So what we have now is the hierarchy. We have the spray particles, and inside the spray particles, we have the dust particles. Why would you want to have this hierarchy? Very simple. Think about if you want to apply forces. When you want to apply gravity, for example, you can say, I'll apply gravity to spray, and that means the gravity would be applied to the dust effect as well, but it will not be applied to the rocks. So that's where particle groups become very, very powerful. And again, as I said, you can access all these particle groups anytime, anywhere, from any node in your scene. Okay, I'll put that back. So the next thing is you would want to create some dynamic sets. And dynamic sets are just containers where you set up your effects. So I would just start here with my first dynamic set, and again, give it a name. Please give it a name. So I name this dynamic set create. And then I have another dynamic set I want to name forces. So that makes it easy. Just spend this extra few seconds. I guarantee you later you will be happy that you know, okay, that's my create dynamic set, and that's my forces dynamic set. And again, we can have hierarchies of dynamic sets as well. I can move this dynamic set underneath create. So now we have a hierarchy. Forces can be affecting only inside this dynamic set. I'll come to that later. However, now we have them all on the same level. So in the create dynamic set, I'm going to create particles. So I can do that by going to the operators and then generators. And I'm showing you now a position born. The position born would just create particles. So I have a particle count, a lifespan, I have all these settings, and let's see if that is already enough. So if I play back now my scene here, you can see, let me just zoom in a little bit more, you can see we have particles at the origin spraying up. So that's how you can create very simple, very fast and effective your particles. However, in the real thinking particles world, that would be just too easy. You want to have more control. So the position born has, and all these generators have this drop down, you can access where you want to born these particles. So now you can decide, okay, I want to born these particles in the spray particle group. So we just put these particles now here. Nothing happens here in the viewport. We just say, okay, if particles are created, they are going into the spray group. If we've done this, now we can affect these particles with our forces. So I'm going to the next dynamic set. So I have my create dynamic set, creates the particles. Now I want to affect it with forces. So in the forces, I'm going now to into our operators, and we have various operators. There's dynamics, and there's a force node. I'm going to use this force node, and I can see right now, okay, this force node doesn't work without knowing which particle I want to affect. And here comes the great power of thinking particles. Now I can decide which particles should be affected by this force. So let's say, okay, I want to affect only my spray particles, because we're borning the particles in the spray group. So I put my spray node here, and it has the particle output. I draw the wire now to particles. So now I have force affecting the spray particles. I have a strength here, so let me just put up the strength a little bit more. I can control direct and all these parameters. However, where is my force pointing to, or where's my direction of force? And you can see I have an input direction. And I want to supply a standard gravity force, so I would go into the helpers, go to the math nodes, and I would just get 0.3, which can give me a vector. So I say, okay, I want a down pointing vector. That would be -1 in the z direction. So now I have created a force pointing down, and the force is only affecting my spray particles, and the spray particles, they have been created in my position-borne dynamic set. Remember here I selected create these particles in the spray group. I can increase these particles to 60, and let's give them a much higher speed. So now I have everything I want, and if we're going back to our particle and I'll play back, you can see we have the particles going here, and the particles are now sprayed here. Let me see that we're in the right thing. Okay, we have the direction pointing down, and we have the particle strength here. Maybe we have to increase our particle strength. So that's how the setup works. So you create the particles, you pick the particles you want to affect, and up here in the taskbar you can see the total of particles in a tree we have created. So now we can see, okay, we have 62 particles in here, and these will be affected by the force. It's a directional force pointing downwards, -1, and that's how we do a thinking particle setup. Okay, let me now show you some more great examples, some more complex examples of thinking particles. Let me just load another scene, and in this scene you will see that we have a little cannon here in the center. And this cannon is shooting a bullet, and we have particles moving just past or by this cannon. So what you see here is the cannon is aiming, and moving back, the cannon is aiming at the closest particle, shooting a bullet. You can see the bullet here. And if that bullet hits a particle, the particle is turned into fragments, and we have the fragments here. So that's our basic setup. Let me just show you how this setup looks like in thinking particles. And again, we have multiple dynamic sets here. Every dynamic set has a function. So here we create the gun. Then we have the gun shape. We assign the shape. We model the gun. We assign the shape. Then we have the alignment of the gun. As I said, we search for the closest particle. We do that with the distance. Then we align ourselves, the gun, along to the particle. We use a threshold and a timer to decide how long this process should be. Then we create a bullet and shoot at it. So we have the targets we create here, the target shape, our bullet shape, and then we have, again with the distance, if it gets hit by a bullet, we fragment the object, and then we even add some rotation to the fragments. So that's the fully procedural setup. And as I said, if you manage to set up your effect fully procedural, you can adjust now the environment where that happens very easily without redoing the animation. So let's say, what would happen if your director comes back and says, okay, one cannon is good on the spaceship, but our spaceship has now 100 cannons. I want this drama. In a thinking particles world, that's no problem at all. We would just draw 100 cannons. And right now, these particles, these cannons are created with a particle, and they're created with a particle draw. So particle draw works like you would expect it. You can just draw these dots, and I'm going to click just randomly around here, and I'm going to create some more cannons. And the beauty of it is, if you have once created these cannons, let me just move one and back. If you have created these cannons, I have just drawn some more cannons here. Every one of these individual cannons knows what it has to do. It will search for the closest particle. It will shoot at the closest particle. Let me play back that now. So particles are flying in. The first cannon down here is the closest cannon to this particle here. I hope you can see my mouse pointer here. So it aligns to the closest particle. And now you can see all the cannons are responding individually based on their rule. So multiple cannons are now in range of targets. And they will all aim and shoot at these targets. And see here, the cannons in the back, they are not reacting yet because nothing is there. There's only fragments traveling, and the fragment is not an object to shoot at. We could make it like that. We could set up a rule, shoot at the fragments and create more fragments. But that's the beauty of what I just showed you about the hierarchies and the groups, the particle groups. These cannons will only aim at our target particle group. So the more particles come in, the more cannons will react and shoot at the targets. And again, that is the real power of thinking particles. You set up your rules, and in this case, it's shooting at a target. Now the director can come back to you and say, okay, I want more planes attacking. I want more cannons. I want faster planes. We can change whatever we want just by dialing in numbers. And you just play simulate, and bam, you're back to the director and say, okay, do you like that now? And we have customers like Scanline, for example, the Scanline VFX in LA and Vancouver. They're using thinking particles a lot, and they have a great pipeline around thinking particles where they actually can do multiple simulations. If it goes into physics, destroying buildings or whatever, they just do multiple simulations in one go, and then you just dial in the different numbers, and then you can present in one go, let's say 3, 4 variations to your director or whoever is responsible for the effect. You present 3, 4 simulations, and he can pick one. And you can do that in one go overnight. And that's the great thing. You don't have to remodel. You don't have to do new keyframes. Imagine the old way of doing effects. If you had to now remodel or reanimate more planes flying there and all this stuff, you would get crazy. And again, you can have rules for your planes flying in a certain manner that can all work in one go. So I think I talked enough about this procedural approach. I'm sure you got it now. Let me go to some more advanced things, because that also works with physics. So Thinking Particles 5 has multiple physics solvers. And I'm going to show you now, let me just, bring up another 3D Studio Max here. Oh, it lost the connection to my Max. Okay, here's my Max. So let me just load the physics scene. I go here. In Thinking Particles, we have another way of doing physics simulations, and in here, let me just zoom in, we have a vehicle simulator. So right now, the great thing is, as I said in my introduction, Thinking Particles is more than just particles.
Hey, Edwin.
Thinking Particles.
Edwin,
Yeah.
your the GoToWebinar screen is showing. It's showing the console, so you probably might want to move that so that the attendees can see the.
Oh, sorry. Yeah.
It's all good.
Yeah,
it's kind of
trippy.
See that
now. I see that now. Okay.
Got it. Cool.
Okay, sorry for that.
No worries.
Okay, so as I said, thinking particles is more than just particles. You can turn any object, any mesh, any animation, any object you have in 3D Studio Max, you can turn this into a thinking particles simulation. And we did that here with a car. And we have this car simulation. We have a vehicle simulation in thinking particles. So you can drive around the car. And this is also done fully procedural. So this driving sequence is done by adjusting the steering wheel in Thinking Particles node in our vehicle simulator. And again, if you overdo it, you can flip over the car, like in reality. So this flipping over of the car is actually based on a physics simulation. If you are too fast changing your steering wheel, it will just flip over the car. And now let me just show you how this works. So a physics simulation, regardless what you do, rigid body, soft body, whatever you do, is nothing else than just a thinking particle setup as well. So let me just start with the first dynamic set where we create the car. That's our bullet physics vehicle node. And what we do here is we just pick a car rig. And the car rig is very, very simple. It's a linked object, so it has a car body and 4 wheels. That's all you need to do. If you have that set up, you just click the car body with the linked wheels, and then you have a car. This car will be simulated. We have the steering wheel here. You can choose, adjust the steering wheel. So if we go through the animation, you will see that the steering wheel, our angle, will change here, and then suddenly it will jump. As you see here, now it jumped, and that will cause the flip over. And then we have forces like gravity, for example, a U deflector so that the car doesn't sink into the floor. And we have our core physics simulation node. Again, everything is fully procedural. You can turn off, on and off a physics simulation at will. That's another huge, powerful feature of Thinking Particles. You can turn off anytime. I don't want now physics to happen. I want to do manual adjustments. Or you turn it on again. From now on, I want a physics simulation. And we do offer multiple solvers. We have implemented in Thinking Particles 5 our bullet physics. And the bullet physics offers many rigid body and soft body solvers. And we have physics as well from NVIDIA. Physics is implemented. And we have our own high quality movie style rigid body physics solver as well. So you can choose whatever solver fits your needs. Thinking Particles has a lot of powerful solvers where you can do physics simulations. Let me just load another scene. So physics simulation works in a way where you can do many kinds of physics simulation. Let me just load this in. Here, for example, we have a simulation of a roller coaster. So the roller coaster, let me just play this back. It goes here, and we have 2 of the sliders where you can adjust the settings. And all you see here in the animation, the rolling back to the loop, all this is physically based, and the main force controlling it is the gravity. So you have an initial speed and a gravity. And again, let's have a short look at the setup. It's also a pretty nice setup we have here. So the first dynamic set is called get stuff. That means, okay, we're getting all the objects in here. We have a node called object to particle. That's the key, what I was talking about. You can turn any object into a particle. So with the object to particle, we get all our wagons or our cars into the simulation. We apply a mass to these cars. Right now the mass is 1. So that's the first thing we do. We get all the 3D models into our particle simulation. So if I just go here, sorry, and zoom in a little bit, you see that we have the cars up here the cars that are going down and then accelerate. So the only thing we have is this initial speed. Let me just go back to the thinking particles setup. So that's, we get the cars in. Now we want the dynamics. We have the force. And one key thing we have changed here is we want to select the first car. We do that with a P selection, and we want to assign, or we want to be able to assign the first car a different mass. And that's the weight of the car number 6, and we have the slider here. And we can access every object in a 3D Studio Max scene with a parent block node. That allows us to access every single bit in a 3D Studio Max world. So we can get the value of the slider and assign it to our first car. And the next thing we have is our path follow. And the same thing is the path follow makes sure that our cars stay on the roller coaster track. So that's actually how this roller coaster thing works. So, and the full simulation is done in real time, and gravity again is the driving force and the speed of the roller coaster. Again, all this is fully procedural, and you can adjust all the parameters at will. You can add more cars, you can add more mass, you can change the speed of the cars, you can do all kinds of things. So I see I'm near the end. Let me just show you one thing where we have soft bodies, because that was a new thing we have in Thinking Particles 5. And after that, I'm done with my presentation, and then we can answer some questions. So I have a spline here. That's a standard spline. I've drawn that in 3D Studio Max with a spline feature, with a shapes feature. And we can turn any spline into a rope. So that's done automatically. You can just draw a spline and can turn it into a rope. And now we can simulate that. I'm forwarding. So all the stuff you see here, including the braking, we can break ropes based on the force. And all the swinging, bending, stretching, everything, all this stuff is done with our Thinking Particles bullet solver that can now simulate soft bodies. And we can simulate the rope, the forces, everything is adjustable in here. So yeah, I could go on, I guess, for another 10 hours. So Thinking Particles is a very powerful system. And yes, it has a learning curve, but I hope I could show you that it's not that complicated. It just can do so much powerful things, and you might have to rethink how you animate and how you do effects. But I'll tell you, that's the experience we get back from our customers. As soon as you are over this learning curve, I guarantee you, you don't want to do anything else, because Thinking Particles is so powerful. You can do such amazing things with it. Okay, and then I guess we just go into our questions and answers session, I think.
All right, thank you, Edwin. Let's see. I'm going to change the presenter back to me.
Yeah, okay.
All right. Let's see. Show my screen. All right. Let me know if you guys just see the slide here. All right.
Yes, I see it.
Cool. Now, we're not going to have time for the Q&A session, but if you guys have any questions, I encourage you guys to send it to Edwin at cebas, or just visit the website. They have a community page there as well. But from the bottom of our hearts, I want to thank you, Edwin, for joining us today, for co-hosting this webinar with us. So for more information about cebas' Thinking Particles 5.0, you can visit their webpage at cebas.com. Thinking Particles 5.0 is the next generation rule-based particle system for 3ds Max and 3ds Max design. It offers an unparalleled power for its users, and in its latest incarnation of 5.0, it redefines fluid, rigid, body, and particle effects simulation in a whole new way. Thinking Particles 5.0 offers true nonlinear animation technology. Rules and conditions control the particle effects and not timers or events that happens at certain keyframes in an animation. A particle system created with Thinking Particles 5.0 will always work regardless of the timing or number of frames that may change in an animation. And hopefully you guys were able to see that today with Edwin's presentation. Now, if you want to purchase the latest version of Thinking Particles, you can visit our product page at Novedge. As a leading online design software store, we pretty much have the best prices around. Pay zero sales tax for Thinking Particles 5.0, and it is now available worldwide through digital delivery. For pricing information, you can always speak with our specialist Bob at bob@novedge.com. Now, at Novedge, we created a community, as a place for users to meet, network, and catch up on all the latest industry happenings. We created WikiCAD as an online place where you can collaborate and communicate with other like-minded professionals. For WikiCAD, we scour the internet for the latest industry buzz to share with you. Furthermore, we encourage community members to participate in the discussion. The process to sign up is a breeze, and with that, you have access to a weekly community newsletter. For access to discussions that matter, sign up and register today. Now, if you have any questions, comments, or concerns about Novedge or about today's webinar, please do not hesitate to email me at kevin@novedge.com. In our upcoming Novedge Best of the Best webinar, episode 61, it is like modeling by hand. This is the model and concept of ClayU for Rhino 5.0. It doesn't matter if you start from a sketch, a curve, or a 3D object. Using advanced subdivision algorithms, learn and see how easy it is to use ClayU to pull, push, and move until your idea comes true. Founder and CEO of TDM Solutions, Rafael Del Molino, will demonstrate and answer your questions about their latest Rhino plugins, so don't miss this. Registration is free, but space is limited, so for more information on how to sign up for this webinar, check it out at novedge.com/webinar/61. Now, if you want to rewatch episode 61 with Edwin and all our other previous webinars, this and past webinars can be found on our Novedge webinar series channel through Vimeo and YouTube, so stay tuned over there. Lastly, you can follow us on Twitter by our handle at Novedge Store, where we'll share with you the latest buzz-worthy industry news, trends, and promotions. So join the conversation and follow us today. On behalf of the team at Novedge, thank you for attending our awesome webinar with Edwin Braun. Cool. All right. Have a good one, guys.